In this video, we are going to deploy one MySQL database in Kubernetes cluster. So after that, we'll expose that database using the NodePort. And once they expose the database using NodePort, then we can access the database from our host system. That is, we are using some of the MySQL UI tool through which we can connect to our remote database instance. So this is the agenda for this video. So this is basically three part. First, we can deploy the MySQL database. After that, we can expose it, and after that, we can connect to the remote database and perform some database operation like create table, those kind of things. Okay. So first thing, that how to deploy this MySQL database in Kubernetes. Okay. So for the MySQL database, we need some of the persistent volume because the database stores data in some of the persistent volume. Okay, so for that we need one of the storage class. You can go through this, what is persistent volume and how to create the persistent volume using the persistent volume claim. So user should request, I need some persistent volume, but they cannot request using PV, they request using PVC. Okay, persistent volume claim. Okay, the internally when I request I need some persistent volume using persistent volume claim as request, then the request goes to your storage class, and the storage class will provision one persistent volume for you so that you can use your persistent volume in your application. Okay, so today we are going to install one of the local storage class. So that is provided by the Rancher, because the earlier we used the Kubernetes the host path. Now they are deprecated or something for the security reason. We cannot access that one. So we can go with alternate solution that like Rancher local class, local storage. Okay, this is the local path provisioner. Okay, so first for the storage class, you can install this one, this YAML file. So let me jump to my demo lab environment. So I am using one node, single node Kubernetes cluster. You can see my control plane is running 1.32 and API server is running on .26 IP address 6443. Okay, so these are the basic thing. All the pods are running. You can see all the pods are running. So now we can go ahead to create one storage class. Okay, so using the Rancher as provider, you can use this command directly, apply this command so that it will create one storage class. Since I already created that one, so we can check using get storage class. The short form is SC. Okay, now you can see it will take like 1 to 2, maximum 1 minute. Okay, you can see one storage class is created, that is name is local path. Once you upload that YAML file, automatically this will be created. Okay, now the important thing is that who is the provisioner. Okay, there is a lot of provisioners available. Now we can go with simple one, that is local path. Okay, it will create one directory in your host system, and from there it will provision the persistent volume. Okay, that's why its name is like local path. Okay, and some of the extra parameters are there. We can cover this in const when we are cover the storage class. Okay, so now our agenda is to install the MySQL database. So we are going with persistent volume request, that is the name is persistent volume claim. So I need one persistent volume. So how we can request that one? Using persistent volume claim. Okay, so let me create one file, MySQL PVC something. Okay, now you can see I created this file, and the most important thing is that you can name your persistent volume, that is MySQL PVC, and from which storage class you want to provision. Okay, so this is my storage class, that is local path something provisioner Rancher. So the class name is local path. Okay, so you can put that name here, and how much request, how much size of that volume you need. Okay, that is you can put using resource request storage. This is the size. Okay, In my case, I am going with like 500 MB or 1 GB or something like that. Okay, if it is 1 GB, you can put 1 GI. Okay, so let me create this persistent volume. Okay, and I'm planning to create this persistent volume to a specific namespace. Okay, so I have one namespace there, dev. Okay, let me check, is there any PVC there or not? You can see no PVC are there. Okay, so let me go ahead to create apply-f PVC. Okay, now one PVC is created. You can check whether the PVC is created. Yeah, your PVC is created. Your whatever name you put there, the same name is reflecting here. And one of the important thing is that the status is showing pending. Okay, so until unless one pod is requested to get this PVC, that for that time it should be in pending state. Then once one pod is created, then automatically this status should be bounded state. Okay, you can see the storage class, from which storage class this one is provisioned. Let me directly create one pod. Okay, before that I can create one service. MySQL deployment. You can see I am planning to create one MySQL deployment. You can see the deployment file, conn deployment, and the deployment name is MySQL. This is the level from how we can, the service is selecting. Now we can go with, this is the important part, this part. Okay, so the container image I am picking like MySQL version 9. Container name is any name, and this one is important, that is the MySQL password, what password you want to set. This is the environment variable of MySQL, this image. Okay, you can put the password, but in real production environment we should take it from Kubernetes secret. Okay, so I'll cover that in the next video. First we can go with simple one. I passed only one variable. Okay, so after that exposed the 3306 port, and this part is important. Okay, so since we have created one PVC, that is name is MySQL PVC, so now we can two section. One is volume and volume mount. Okay, MySQL data are stored in this path var live MySQL. Okay, so we need to attach this volume to this path. Okay, so how can you attach? Using this tag. One is, first we define one volume. Okay, volume name is any name. Then in volume, when you define the volume, that time you can refer your PVC. This PVC name should be matched with your created PVC earlier step. Okay, now once you created the volume or define one volume, the same name should be created here when you mount that volume. Okay, now I am going to mount this volume to this MySQL path. This path you cannot change. This is the predefined path in the image. Okay, image itself. Okay, this path is fixed one. Now your PVC is mounted on this directory. Okay, so let me go ahead to create this one. Apply MySQL deployment on the dev namespace. Then we can expose that service using NodePort. Okay, so let me check that one. MySQL SVC. You can see I created one service, and whatever label I passed there, I can select the service using the selector. Same label app equal to MySQL, so same selector is app equal to MySQL. Then this part is important, port. Okay, so I expose my container port 3306. So here also the port I defined this one, and the target port is whatever this port is, this port should be matched. Okay, and important thing is that I want to expose this application, this service using NodePort. So that's why I added this line type NodePort, and type NodePort, then whatever node port you want to expose, like 30,000 plus, okay, 30,006 or something. I put there. Okay, let me create this service itself. Okay, SVC. I think earlier it was created. Okay, let me check what is the status of this this component. Get all from this namespace, that is dev. You can see one service is created having name MySQL node port or something. Okay, and it is exposed on whatever port you given, and that port it is exposed, and your MySQL database pod is also running. Okay, this is the MySQL database pod. Okay, and this is the deployment, and this is the replica set, like that. Okay, so now we are going to access this database first, whether it's working or not. So how to access this one? You need to exe to that pod. Okay, you draw dev, then exe it interactive, then I want to log into Basel. Yeah, so now you can see I already in that container. Whatever the pod you mentioned here, I already log into that pod. Okay, so let me check what is the like MySQL version or something. Okay, so for that how to log in, because whatever root password you given that time, you can use that password. Okay, so the command is this one. You can directly log in using MySQL command prompt. MySQL, the host name is not required because we are already in that pod. It asks for the root password. You can pass. Now we can see the MySQL prompt is coming. Okay, means the database is still running inside the pod. Okay, so you can see what a lot of environment variables are there. I think it's not at here. Okay, now we can check or create some of the database. Okay, so for that I have some document available. Yeah, these are the document from the Oracle side. You can pick show database. These are the basic commands. Okay, show database, you can see these are the predefined database. Okay, let me create one database, that is the spread database. We can check whether we are able to access this database outside or not, and we can use that database pets. And let me go ahead to create one sample table. Okay, that is cat, and you can check if that table is created or not. So table is created, and you can insert some of the data inside the table. I will make it faster so that okay, and you can fetch the data from your table. Okay, like these are the table data. Done. So that is 3 rows inserted in the table. Okay, so now we can exit this database, exit here. Okay, so now we can check all the pods should be in running status. Yes, now we are going to access this database using this NodePort. Okay, so how to access this NodePort? You can pick any of the your worker node IP. So you can, this is the worker node IP. Okay, we can use this, and port number is this one. Okay, this is the node IP. So for that we have another MySQL tool is there, that is MySQL workbench. This is the GUI tool. So you can get your UI interface from there you can connect. Okay, so since I'm running all this application inside the virtual machine, that is Ubuntu virtual machine, which is hosted by the VirtualBox, let me connect from my host machine, that is a window machine. Okay, So I already installed this MySQL installer, that is it is not the MySQL installer. This part only you need, MySQL workbench. Okay, the size is around only 40 MB something. Okay, this is very small size, and since I already installed, simple double click it will install. Okay, since I already installed, from my window host I am trying to log in. Okay, this is the first phase of your MySQL workbench, where I mean I already installed in my host machine, that is window host. Okay, from window host let me connect to the database running inside Kubernetes cluster using NodePort. Okay, so this is the third phase of our demo. You can simply click on MySQL connection plus button. Okay, now this window is pop up, and here you can, the connection name you can put like MySQL NodePort demo. Okay, but connection whatever. Okay, then this is the important thing, host name. Okay, in the host name you can put your any of your worker node. How to get this one? Get node -o void. This is my single node Kubernetes cluster, so that's why I can pick this host IP, I mean the host only interface IP. Okay, I put that 26.26, and I exposed the node port using this number. Okay, that is 3006. Okay, instead of default 3306 I should put this one. Okay, and the root user default selected, and here you should pass your password. Okay, so when we are creating the database, so that time we passed this as password. Okay, so we need to pass this one, PASSWRD password, whatever you put the same, and the default leave the default schema. Now click on the test connection. Now it is showing like connection warning because MySQL server is running 9.3, but my workbench GUI is using some of the lower version, so that's why it's throwing some information. We can click continue. Now we can see it is successfully connected to my database. Okay, click OK. Now you can see one connection is created and showing, and here click on this one and it will show you some warning, continue anyway. Now you can see there we have created our pet database. Okay, if you scroll off, you can see we have created pet database. Okay, and there we created one table, that is cat. Okay, and 3 rows already inserted. Okay, the same pet database you can check here and go to table section. You can see one cat table is there, and there is a lot of table columns are there. You can fetch your data. Select star, simple command, star from your database name, that is pets dot, it will automatically come cat table. Now you can select this line and run. This is the run, this spark symbol. Now we can see all the 3 records are coming. Whatever record you inserted there, all are coming. Okay, so if you insert some of the records at here, then automatically it will show at here. Okay, so let me quickly insert some of the table record. Go to edit from the UI. So I can put like name is pet name is something x1. Okay, and owner is like y1, and birth is like 2019 0503. Okay, the name is x1, y1 and 2019. Okay, so after you click here, then one apply button is there. Okay, apply, it will generate the SQL command, insert into this and this value, apply, why this error. This date format is incorrect. I think we missed one of the hyphen. Okay, now you can apply this one. Apply, done, finish. So here we added one row. It should be reflected in our database. Okay, so let me go ahead, log into that database pod. The command is this one. I will copy this command for your reference. exec then your database, database pod. Okay, now we are into the database. Let me log in using MySQL as password. Okay, now the command is same, use database something. In case of create table, we can use use pets, then select start from, what is that table name, cats. Now you can see 4 rows is selected. Okay, the whatever entry we made there in the GUI, the same entry is coming at here. Okay, so this way you can install any database like MySQL database and how to expose the database using the NodePort and connect from your Windows machine. Okay, so once everything is completed, then you can if you want to clean up all these things, most probably I will cover that in another video, how to clean up all these things, because the procedure is different. First you can delete this deployment and service. After that you need to delete the PVC, that is k delete PVC name, then automatically the PV will be deleted. Okay, this is the reverse procedure you need to follow. First you need to delete pod, then service, then PVC. Okay, this is the reverse procedure. Okay, so that's it about this today's demo. Thank you guys.